Spatial momentum moving on from the first part. So in this case, we need the mass of the first rider, the mass of the second rider. We'll get those using the balance. We need to get the initial velocity of the first rider while the second rider is at rest. So the momentum before will be the momentum of the first rider, which is just mass multiplied by initial velocity. We get the mass from the balance, as I said, and we get the initial velocity as we just did in the velocity experiment using gate 1. The rider will then move on and it will hit the second rider. You will note that we have a situation here where we have a pin and a cork, or a pin and blue tack, so that the two of these will join together. When they join together, they will move on like this, go through the second gate, and the second gate will measure the velocity after the collision at that stage. So we'll have the mass and the velocity before the collision, the total mass and the velocity after the collision, the total mass after obviously being the mass of the two riders together, and we're in business. So step 1, get the mass of rider 1, 126.8 grams. Step 2, get the mass of rider 2, 144 grams. Step 3, find the initial and final velocities. Sorry, I need to put this in the middle here. Okay, now I need this rider to stay at rest. So normally if you have a partner, you will get the partner just to keep the finger in to make sure it stays at rest. Hopefully we have it horizontal, so it should stay at rest anyhow. So I'm going to turn on I'm going to reset that. Okay, turn on the air track, wrong switch. And off it went. Okay, we'll turn it off. Okay, and we have 2 times here. Okay, we have gate 1, it took 0.049 of a second to pass through, and gate 2, it took 0.161 seconds to pass through. Okay, we have, again, we need to get the distance travelled. Okay, so to measure that accurately, it's, as I said before, 10 centimetres. So now you have all the information you need. Okay, you have all the information you need. Remember, you have reduced friction by having a cushion of air between the air track and the rider. A cushion of air must be said, and you have a horizontal air track. Okay, you have the data to do the calculations and verify the principle of conservation of momentum. Remember, hugely important, you must put in the unit. So momentum before equals whatever, kilograms meters per second. Momentum after equals whatever, kilograms meters per second. People always forget to put in the unit. Don't be people.